Media contributing editor, and Help Me Stream Research Foundation founder and CEO, I believe, Tim Siglin. Tim, take it away.
There we go. Executive Director is probably a closer title, but yeah, thank you, Eric. So the topic we're going to talk about today is AV1, and we've subtitled it A Reality Check. And I think that's one of the things that, as we've talked to a number of people across the industry, we know that AVC, for instance, H.264 has been around for quite some time. In fact, I came out of video conferencing before I was in streaming, so I've been using 264 for almost 20 years. It's been sort of remarkable how long it's stuck around, but there's a new batch of codecs out in the space now that address not just quality, but also some of the licensing issues. This forum today is a technical forum, not a forum around licensing. We've got technical people aboard, so we're going to actually focus that direction. If there are questions that come up around licensing, we can look to see what we can help you get answers with offline. With that said, I'm going to go ahead and ask the panelists to introduce themselves, tell us what company they're with, and a little bit about their time in the industry. And on my screen, I'm going to start right to left, so I'll be starting with Anush. So Anush, if you'll introduce yourself.
Hi, my name is Anush Moorthy. I lead the video and image encoding team at Netflix. Our team is responsible for the encodes that hopefully all of you see and pay my salary with by subscribing to Netflix. Our team essentially is always looking for the next generation codecs, implementations, doing quality evaluations of different generations of codecs, and making sure that we have the best in class encodes for our members. I have been at Netflix for the last 4.5 years or so. And before that, I was at Qualcomm in the video team developing chipsets for their Snapdragon processor. And then before that at Texas Instruments, again, in video and imaging.
Interesting. I remember watching, I go to Mobile World Congress every year, and watching one of the Snapdragons do 4K with surround sound audio was just phenomenal to realize that was coming out of a phone. Was the TI work in the DSP space for DaVinci and that type of thing?
Yeah, so TI used to have an OMAP processor, for those of you old enough to remember. It used to go into the Nokia phones, and they had an ISP sitting on there. So I was in the ISP team for the camera.
Okay, got it. I am old enough to remember that. I turned 50, so apparently that makes me able to remember all the way back to before real video even. So, all right, moving on. Vittorio, introduce yourself, your company, and a little bit about your time in the industry.
Hello everyone, I'm Vittorio Jovara. I lead the encoding team at Vimeo. We take care of everything that happens to the video once the user is uploading the file, and so we converted it to be available on the iPads, on the TVs, on the desktop, and we also make sure to stream the video and package it as smoothly as possible. My time in the industry has been 5 years now, 5.5 at Vimeo here in New York. And before that, I was mostly developing open source softwares and tools, mostly X264 and FFmpeg.
Very good. And we all noticed the VLC pylon in the corner behind you. That's actually probably the coolest background today, because yesterday we had a bunch of people doing guitars, but I love to see that pylon and sort of the open source that envelops. So.
The cone is in our heart.
Ah, very good. Paul, go ahead and introduce yourself.
Hi, I'm Paul MacDougall. I'm a principal sales engineer with Bitmovin. I've been with Bitmovin for a bit over 3 years now, and yeah, we've been very excited to see the progress that's been happening with AV1. So
good, awesome. And Nathan, I understand you also have the cone.
Oh yeah, I saw Vittorio, so I got mine out. So yeah, Nathan Egge from Mozilla. I manage our codec engineering team here at Mozilla. I've been at Mozilla for 8 years, so this is the work we do on AV1 and Opus, plus other standardization work in terms of getting some of these formats into other open protocols, so like WebRTC and other things like that. And we before we worked on AV1, we had a team working on DAW. So a lot of the technologies that we moved into AV1 were work that we actually researched on for a number of years before AO Media existed.
And DAW was actually a really interesting approach. And then there were other, audio codecs? Was it Theora? Was that?
Yeah, so a number of people on my team actually have been part of the Ziff.org Foundation since the late 90s. And we had Theora, we had Vorbis, Kelt was one, Speaks, and then some of that technology got rolled up into the Opus format when we partnered with Skype and later Microsoft on it.
Okay, interesting. So for those who don't maybe understand what Alliance for Open Media is, can you just give a quick overview on that? Because obviously in the world of MPEG, you've got sort of very clearly defined roles in terms of the standards committees and then the patent holders and the licensees. But tell the audience what AOM is so that we understand that.
Sure, I'll do my best shot at that. So AO Media, the Alliance for Open Media, is an industry consortium of a number of technology companies, both in the software, hardware, service provider, and other spaces that all join together to pool their technologies to make a best-in-class video standard, video compression standard. The name implies that there may be other work we could do kind of in the media space, but for right now, the focus is really on the meat and potatoes of video compression.
Okay, awesome. So one of the conversations that we've had before we started today was around resolution versus quality. And I'd like to open this up to the panel, but I'm going to start first with a sort of the way upper end. Paul, you had mentioned the concept of 8K and using AV1 for 8K. Do you want to talk a little bit about that, and then we'll bring it back down to 4K and even 1080p?
Sure. So I think, under the hood of AV1, or sort of one of the biggest driving parts of it, of course, is that you're getting a better efficiency out of the codec. And when we look at what it takes to deliver such a large size piece of video, you really need to have that extra level of efficiency to make that practical for many people. I mean, I think quite a bit of our audience here today, certainly the members of this panel and so forth, as we were talking about before the panel started, we all have very good internet connections. We're probably going to be on the cutting edge of that for what most people in America and around the rest of the world and so forth have. But that's not the case for mainstream audiences, I would say. And in order to be able to reach those audiences, over the connections that they have, you're going to have to be able to deliver that much more efficiently, as well as obviously the related costs that come into play with delivery in itself. So CDN usage and so forth, of course, is going to go considerably when you have such a large size piece of video trying to be pushed through those pipes, which multiplies itself as a cost. If you're delivering a video at one size or a much larger size, that cost gets multiplied out every time you have to go stream that. I think that's one of the reasons why, especially amongst the larger companies, we've seen so much eagerness to adopt AV1, I think for especially their sort of more popular content that we've seen elsewhere.
So, I mean, do we expect to see AV1 in 8K TVs? What does it mean in terms of chipsets? What does it mean in terms of power consumption? Because I think that's also important.
Yeah, absolutely. And I think especially when we look at some of the recent announcements that came out of CES earlier this year, AV1 was really the 8K codec of choice. In fact, I'm not aware of anybody who was stating delivery through any mechanism besides AV1. So I think Samsung probably was the one that made the largest headlines around that. They really pushed AV1 as being sort of marquee feature for their 8K televisions, although actually every 2020 model set from Samsung has AV1 decoding support. Of course, that's really more about having the application-specific integrated circuits that you would need in order to decode that in sort of a lower processing power environment as we tend to see in a smart TV, because they don't necessarily have as need for the beefy CPUs, but they do have needs for those very specific use cases of decoding complex video. Power tends to be, of course, somewhat less of a consideration. You always want to be efficient with power as you can, but if you're plugged into a wall outlet, you're not necessarily going to be as concerned about that. I think where we'll see that becoming a much larger concern, where it's really relevant, is when we talk about mobile delivery for that. So not necessarily those 8K resolutions, but handsets, of course, are where that's really going to be making the big difference.
Okay, and speaking of that, so from a Netflix perspective, from a Vimeo perspective, AV1 for mobile content, what kind of benefits do you see there? What kind of uptake do you see there versus somebody looking at it on a set-top box or a smart TV?
I think with every generation of codec, it's always true. So even it's true for AV1 is that it attacks different use cases differently, right? And it is beneficial across the spectrum. So the 8K type use cases make sense in high-end TVs, maybe in immersive type displays, possibly, right? All of those cases where resolution starts to matter. And as you move down the resolution, when you hit, say, the phones or mobile viewing environments where we see a lot of viewing actually outside of the US, most of the world views a lot of stuff on mobile displays. There's huge benefits to be had. And the case in point is the recent pandemic, right? And many of you would have heard headlines, YouTube, Netflix, several other companies were actually asked by governments, and some of them voluntarily reduced the amount of bits that are being thrown out on the internet, right? And this is essentially to reduce congestion. And a 20-25% bitrate drop that we typically see even at lower resolutions and qualities that we stream for mobile and other smaller devices, that makes a huge impact given the subscriber base, given the amount of video content that's actually being streamed on a daily basis. So in my head, it's different use cases and there's benefits to AV1 in every single one of them. For Netflix, I think currently it's mainly the TV downward, but there may be 8K and so on in the future.
Okay, interesting. Vittorio, from a Vimeo standpoint?
First, on the mobile point, I think Netflix should be praised even more because they are one of the sponsors of David for mobile. David is the AV1 decoder, and that is an open source project from Netherlands, and it's the fastest and best piece of software ever released around this codec. And Netflix sponsored a lot of work for 10-bit decoding on ARM. And this is a fantastic requirement for HDR. And HDR on mobile is probably going to be a reality really, really soon.
Okay, interesting. So Nathan, from your standpoint, what are some of sort of the sweet spots or mainstream use cases for AV1, and then what are maybe one or two of the fringe or edge cases?
Yeah, I think it's been mentioned a little bit already, but kind of directly, we're seeing the enablement of reaching a broader audience with this more advanced codec, because we're able to do delivery of smaller videos, and that actually scales not just up at the larger sizes at 8K and 4K, but all the way down to some of the renditions that would be going out to places with limited data connectivity, right? So you think about like your next billion users and these emerging areas that don't yet have the infrastructure that North America has. AV1 is really important because it lets you reach that audience. And I think Aaron from Netflix has said a couple of times that they don't want to be responsible for using the entire data plan of a consumer to like watch one show, right? Like if you're gonna go binge watch a show, like it shouldn't eat your whole month's worth of data. And I think that's a really important point, right? These are quality of life improvements for a large set of people that are really enabled by this technology.
Interesting. So when it comes to things like quality versus resolution, and I'm going to throw this out to the whole panel, conversations that typically have been had around AVC were about how much better it was than MPEG-2. And then, of course, what we've seen over the last couple of years, especially I worked with a context-aware encoding company, was we could get 10%, 15%, 20% gains in the 1080p space. Obviously, there's significantly better gains when you go into 4K. But even for 1080p, is quality a differentiator for AV1 versus, say, the traditional AVC model? And how is quality measured?
I can start and then the others can chip in. So one is, in general, we've been trying to disambiguate resolution from quality. Quality is quality, resolution is resolution. Increasing resolution did not necessarily always mean quality, just like increasing bits does not necessarily always mean increasing quality. We've come around to the view that quality is a function of several things. It's not just the encoding quality that matters, it's the quality of experience that matters. So I can send you, I don't know, a 10 Mbps stream, but if you have to buffer every 2 seconds to play 1 second of video, that's a terrible quality of experience, right? So there are several other factors at play, and that trade-off is very important. But purely from a compression standpoint, we've been using VMAF, which is the algorithm that we work with universities, and we constantly improve for different use cases. And we found that there are many algorithms out there, of course, PSNR being the more common one to measure objectively the quality. But we found across databases and for several of the use cases that the panelists on this forum target, VMAF has been a very, very good quality metric. So it generally correlates very well with what humans say. And then now going back to the other question on AV1's quality performance, we found that AV1 with VMAF as the quality measure easily gives you quality, equivalent quality with 20-25% reduction in bitrate across the spectrum.
Across all data rates or specifically?
Yeah, across resolutions, right? And then of course, as you pointed out, as you go higher, you get slightly higher compression. But 20-25% seems like a very easy rule of thumb to keep in mind.
Okay, good. I want to come back to VMAF in a couple minutes, but the other panelists in terms of how we sort of look at quality versus resolution sweet spots.
Yeah, I think we've, sorry. Please, Nathan.
Sure, I just wanted, because you asked me for fringe cases, and I thought this might be also useful to bring up, is that last summer, Cisco did a presentation about their use of AV1 in collaborative products like WebEx. And there, they were talking about some of the ways that AV1 lets them enable better quality of experience for their users, even at a reduced data rate over AVC. And so they were actually quoting numbers, I pulled it up here, that 1080p 30 was using, 2/3 the rate of 264, this 1080p AV1, 2/3 the rate of 264 at 720p, right? So they can actually reduce the rate and improve the resolution and deliver a higher quality of experience. And so I don't know if this is necessarily a fringe case, but I wanted to point out that there are things that aren't just the streaming use case.
Well, and I was going to say before the other panelists go on, I think that what you just said there, on some level, as you go out and talk to content providers or artistic directors of photography, etc., if you can say to them, I can give you 1080p at 720p data rates, that's a really interesting conversation to have versus I can give you a 15% reduction in data, because that doesn't correlate to what the average artistic person is looking at in terms of measuring what they're going to use to deliver their content. Paul, Vittorio?
I was going to say that, I think similar to Nathan's point there, we do a lot of analysis around this, particularly with regards to our per title encoding. And I think it's really interesting when we see where resolution can or does not benefit the perceived visual quality. So for example, if you look at animation content, you can see much better results by putting your data towards resolution than you would just at a higher data rate for a smaller frame size. So we see better looking video when it's a 1080p at say 500 kilobits than when it's say a 360p at 600 kilobits, because those sharper lines that you get from that higher resolution are going to be much more apparent to a user. If you have something that has I don't know, maybe a texture like grass or something like that, and that texture might not be as meaningfully represented, it might be more accurately represented by resolution, but it might not be as perceptually represented by resolution. So if you have perhaps a sports player or something like that, somebody quickly moving across the scene, you're going to benefit that much more by spending that resolution on that person moving. So that's what's going to lead to that better end user experience. So I think we really can see that there's definitely not a linear relationship. And also, it's interesting, I've had discussions lately with customers, or I had a discussion recently with the customer that was really examining the quality of video through, they were using a method that was based upon bits per pixel. So, taking the raster size and how many frames you were using, and then dividing that, the bits used for that to come up with this number. And they were using that metric as their way to determine video quality. But Of course, that really doesn't, I think, give you a good understanding of what the end user is going to see, you know, how they're watching on their display. And that's what really matters at the end of the day. I think that's what I think the VMAF metric in particular has really been striving towards, simulating what a person sees, how they feel about that video in their home, how that communicates what they're trying to understand for it, not just a, you know, a mathematical formula that might provide some sort of, you know, easy to understand number that doesn't necessarily really give you a good indication of what you're seeing when you're watching that.
And I'll add to that, Paul. I think what you have is BPP is sort of equivalent to what PSNR was in the early days. You might hit that number, but when you looked visually at what was there, the content wasn't very good. What it seems like, or potentially could not be as good as would be expected from the numbers. What it seems like with VMAF and some of these other human visual system mimicking algorithms and quality metrics is that we really are trying to address that particular issue of, if we had golden eyes look at it versus we have the algorithm look at it, that it should correlate out fairly consistently. Having said that, working in the world of uncompressed video, BPP is one of those things that we obviously look at from an efficiency standpoint. So it'd be interesting to see if we could get some metrics down the line that would allow us to measure sort of both of those, a high computational efficiency, a high BPP efficiency, as well as a good visual efficiency.
Bits per VMAF?
The BVA, maybe, I don't know. It'd be a long acronym. So. I think, Vittorio, you were the last one on the list for this sort of question on quality.
Yeah, I would like to come back to Anush's point. It's really hard to use the same quality definition that we've been using for AVC. For this new generation codec, I'm counting HVC, VP9, AV1, etc. There should really be more aspects to it, to just a resolution. I like to introduce the three aspects of quality: the spatial, the temporal, and the spectral. The spatial is the just increasing resolution, which is the normal quality metric that we've been using so far, more or less. Then there is the spatial, which is increasing the frame rate. The higher the frame rate, the better the image for the viewer is. And then there is the latest, absolutely latest one, the spectral, which is increasing the bit depth and improving the color space. And in that regard, HDR has been the greatest and newest technology that has been available for video in the last few years, I believe.
And I think bit depth is very important, as you say there, because the more bit depth you have to work with, the better off you are from the standpoint of actually perceiving the differences between shades of black, etc. Nathan, you had mentioned something before we went on the air on the bit depth standpoint from AV1 having an internal bit depth that can be deeper than what is put in versus what's put out. Can you talk a little bit about that?
Yeah, just briefly. So, you know, a lot of the quality artifacts that users see, right? They might see some very low contrast area with banding. You know, there's the famous Game of Thrones scene, but I've also seen it in plenty of sort of sky scenes. And that's really due to quantization error, right? And one of the ways you can address this is if you have a codec like AV1 that has a higher internal bit depth that it uses, that lets you avoid some of the heavy banding. Obviously, there are dynamic range issues and things like that. But you know, this is an area that was added in AV1 development that lets us have this higher internal bit depth path that should address that to some degree.
And it's interesting that you described that, because having worked in motion picture, when we started using After Effects, we would bring in 8-bit content. We would process it at 12-bit because concatenation issues and the like, and be able to spit out something that was 8-bit that still had a better perceived quality. So that's really intriguing that that's built into the codec itself. Does anybody else want to talk about HDR or SDR? I know yesterday we had questions in Content Delivery Summit around whether you could re-encode standard def content using an HDR color bit depth and end up with better quality. But just want to leave that open to anybody else on the panel to talk about HDR.
Vittorio, do you want to go?
Oh, I'm just saying I'm a big proponent of HDR, mostly because it improves the perceived quality, air quotes, of the video without having to necessarily to increase the bandwidth. So if I'm able to receive a 1080p stream, I can also receive it at HDR 1080p stream. And so this technology has a much better penetration than 4K that has bandwidth requirements as well.
Okay, Anush?
Yeah, the point I was trying to make was we've all grown up and lived with SDR for so long that we expect the world to look like our old screens, right? And not the world that we actually see outside of us. But when you look at well-mastered HDR content, you realize there's a lot that we're leaving on the table. By just increasing the bit depth and mastering it right, you get the experience is it's I don't know, hell and heaven, I guess. And it just boils down to there's a huge mindset change that's needed, that as the color graders start to use the technology better, and the film, it's not just the color grading, right? It's also the filmographer, the cinematographers need to set scenes so that the pop comes in, right? And we see that growing. As that occurs, just those 2 extra bits would give you so much more than simply increasing the resolution 4x, right? I think there's like a lot we've left on the table. So I'm a big fan of HDR, especially with AV1, right? And I'm hoping to see far more eye-popping content than we've seen in the past.
And I think from a practical production standpoint, typically we're shooting in 12-bit anyway. So we've got a much, much wider, what we used to call number of stops, but in fact it's dynamic range. And as you say, if you can sort of address those banding issues of really white whites or really black blacks, being able to move things 1 stop or 2 stops up and then fit it within the HDR range that we have with 10-bit, that actually brings it closer to what we would see visually as well. So very good. I had a couple questions from the audience. Let me check real quick. First one is, talk about AV1 for stereo pair 3D video encoding and whether there's an MVC equivalent in the MPEG world. Paul, you brought up the idea around VR, and resolution. So I'm going to throw that one first to you, but I'd like anybody else on the panel to talk about sort of how AV1 handles things like VR, stereo pairs, 3D video encoding.
Sure. So I think it's kind of an interesting topic right now in particular because, VR maybe got a little bit of sort of fell out of favor in the market a bit. But I think now as we see more people, spending more time indoors, and also I think with, finally having maybe the first VR killer app with Valve's Half-Life Alyx, we're seeing, I think, a lot of increase in the addressable market and the demand for VR. And we could talk about 8K TVs and the fact that for most people's use cases, the size that most people's viewing areas are, the size of the TVs they're likely to have in those environments, the appreciable benefit of 8K versus 4K can be fairly negligible. However, where we can see a really significant benefit from that extra resolution is in VR, because you are taking, that piece of video and you're stretching that out, to look at only a small segment of that at any particular moment. Having as much resolution as possible is really, really beneficial. Also because, you have that screen, right up, as close to your eyeballs as you can get it with, the appropriate optics and so on. That's an area that we can see, I think, 8K and the bandwidth benefits that we get from a codec like AV1 really making a noticeable and appreciable improvement in the quality of the end user experience there, because it's you're trying to recreate reality, and the more pixels you can throw at that, the more resolution you can throw at that, especially since you're stretching out that resolution, you're kind of disposing of so much of that. That's something where it can really make a large difference to an end user's experience there.
Interesting. Other panelists?
I can maybe speak about the MVC side. I'm not really a fan of the codec. I think it's one of the most over-engineered and complex codec that MPEG ever produced. And most in the one of the shortcomings is that it is so complex that but there is basically no implementation out there. And so in the interest of engineering, it's probably better if AV1 and all the feature codes don't have such a complex system. For the time being, the frame packing, stereo, and the VR are probably good enough for the current level of compression generation we are in. Okay.
Sounds good. A second question came in asking if there could be some form of comparison between real world processing times of HEVC versus AV1. I know a year or so ago when AV1 came out, one of the things that just sort of became standard was people ridiculing the length of time that it took to actually do encodes in it. We've obviously made progress on that. Nathan, how much progress have we made from that standpoint?
That's a great question. So I can tell you that it is somewhat embarrassing that at the get-go, the libaom, the only public AV1 encoding model was embarrassingly slow. And over the year after that release at NAB 2018, I do know that it got, I think, 16 or 17 times faster. But the reason that question is a challenging question is that there are many operating points, right? And again, I like to point at this presentation that Cisco did because they actually made some statements about comparing their work optimizing AV1 for real-time delivery, or I guess interactive delivery, versus the work they did at HEVC. And they were saying that even, you know, after they've applied all the tricks they know, they were still able to get better compression in an interactive environment with AV1. And so while maybe that development is lagging in some of the open source models, right? I don't know that we've got there exactly with any of the open source encoders for interactive. It's certainly possible, right? And I think that'll extend to other use cases.
Okay. Paul, Vittorio, Anush, any comparisons that you all have done in your work?
I think we've got some, at Bitmovin, I think we had some good examples of that improvement. When we did an AV1 live stream at NAB in 2017, it took us about 200 cores or so to do that as a live 1080p stream, and I believe it was about somewhere in the 2 megabit range. And then it was roughly like a year later, maybe at the next IBC or somewhere in that neighborhood, we did the same quality stream, visual quality stream, roughly, with low double-digit core counts. So by being able to do some of those sort of early optimizations, I think much of what we saw from the libaom and so forth, we're able to dramatically reduce that resource footprint required to do that in a real-time manner. And we're still talking about a codec that's barely getting any in-market usage right now, I think, compared at least to AVC. And even in AVC, we still see regular improvements in the quality per bit that we're able to get out of that. So there is, I think, a long way to go to improve AV1, both from a compression ratio standpoint and then quite obviously from a resource requirement for the encode side too. So I think we're going to see that continue to become much more efficient, become much more approachable for customers, for content delivery and content providers.
I want to chat a bit about the encoder complexity, right? So I know Nathan said it's a little embarrassing that libaom was terrible, but I come from slightly different perspective. It's that during the development phase of a codec, the code base need not necessarily be optimized, right? And libaom, we should think of it, at least in its origins, was a research code base, right? You put in tools, you tried different combinations, and you tried to make it work, right? So there will be a lot of code that's not optimized at all, that's poorly written, that's written by, say, a PhD student in some cases, right? Whose goal is a paper and not really optimization. But once the standard's set in stone and you've published the spec, then is when the people who know what they're doing, because there's a group of people who know how to develop algorithms, and there's a group of people who know how to optimize algorithms. And X264 has shown that very well, right? So once that's done, you hand it off to the people who know what they're doing in optimizing, right? Using the right set of resources, like I think Vittorio pointed out earlier with David's, all of the effort that Videoland's doing, optimizing David across the spectrum for different chipsets on the decoder side. Similarly, similar expertise exists on the encoder side. And we've seen developers now start to develop different codecs, either hardware or software, optimizing it using all the resources available. So this could be, say, assembly or ARM or x86 type optimizations. This could be using GPUs offloading. This could be using a plethora of tools that are there, which are kind of not important while you're developing the codec, right? And then just as anecdotal numbers, right? Please don't quote me on this too much, but we've actually internally tested out several production grade AV1 encoders. I don't know if I would qualify LibOM as a production grade encoder. Maybe in the last 1 month it has changed, but production grade encoders are say, depending on the operating point, which was also pointed out, within an order of magnitude of complexity of the previous generation encoders, right? So a multiplier of 6x or 5x, depending on where you're operating. And in my head, that's a perfectly acceptable trade-off, given that we still have some more efficiency to squeeze, as Paul was pointing out, from people who actually know what they're doing when they're optimizing encoders.
Well, and I'll add something as well to what you just said there, Anush. To a certain extent, doing an open source codec, just like doing stuff on GitHub for anything that's open source, is allowing people to see how the sausage is made. Where when you go to the MBEG model, typically it was work that people had done internally at their companies, got it to the point where it was mostly optimized, then put it out to be put into the standard and then put into a patent pool to, essentially make the money back on it. So you're right. We all got a chance to see it at a point where it was not optimized, and we're all also getting a chance to see it as it continues to be optimized and fine-tuned for GPUs, etc. I'm getting a ton of questions coming in here, but one question along those lines that I want to ask, let me find it here because it had to do with GPUs. The question, Vladimir Menenkov asked, are there current attempts to make GPU-enabled encoders for AV1, sort of like NVENC for H.264, H.265? And again, I'll throw that out to everybody on the panel.
I haven't seen any GPU-specific libraries. I mean, certainly there's Intel has released some hardware-specific, CPU hardware-specific encoding libraries, and then I've seen also some work around FPGA accelerated encoding, but I haven't seen any GPU, any kind of libraries from NVIDIA or anything like that yet available for AV1 encoding.
Okay. Anybody else? Feedback on?
I'll just very briefly comment that, the design of the format did allow for some amount of offloading. I mean, I think it had a bunch of input from many of the hardware vendors, so I do expect them to eventually be able to say something more strongly about the availability of those encoders. But because we got their feedback, if you look at, say, the David decoder, there's an effort right now to do GPU and accelerated decoding for some of the post filters. And that work is, again, directly applicable, right? If we can do things in CUDA or other GPU-based languages, we could also incorporate those into, say, the open source encoder that Mozilla and Ziff are developing. So I think that there's some opportunity there.
So decoding is another, sorry, did I cut one of the panelists?
Yeah, I was going to add to that. In terms of like the life cycle of a codec, the first set of optimizations we should see, and which we are seeing, is on the decoder side. So you see first the CPU, you hit the low hanging fruit first, right? So you first just code cleanup, just better code. Then you hit all the assembly, you hit all the CPU optimizations, and then you start to do the GPU offloading. And then once you've squeezed out every single bit of performance of the decoder, then you look at encoders, right? So maybe there are others who are looking parallelly as well. But the decoder is really the kicker because you want to optimize for power, you want to optimize for, ubiquity. And then the encoder, because for the most part, most companies are doing this on servers. The cycle for that is much longer than for decoder. But I have seen several decoder efforts for sure on the GPU space.
And not only that, I think what we see sort of traditionally in codec development is as a codec stabilizes, you'll start to see it for things like GPU and FPGA and ASICs. Prior to that, you want to stick with sort of general purpose computing, whether it's ARM or traditional x86, so that you can make tweaks to it and like that. But you brought up the point on power consumption, and there were two questions here. I'm going to try to sort of combine them together. One was the question about 8K video. So I think, Paul, this is probably going to go to you. It said essentially, 8K video is only available through PC browsers and other formats, but those announcements at CES 2020 around 8K videos with AV1 and 8K TVs, is the intent there to start first with televisions and then move to browsers? And if so, is it going to be all hardware based on the decode side for televisions, or are we finding this balance here somewhere that it's firmware updates into a smart TV that sort of keep lockstep with PC browsers so that companies like Netflix and Vimeo can show their content across multiple platforms?
I think it's probably going to be more, hardware-based decoding that we're going to see in those TVs. I think that's pretty much the approach that we've seen really follow through with smart TVs for many years now. It's actually one of the reasons why deploying a lot of OTT experiences on smart TVs is especially challenging, because all the power in there is around those decoding processors and the kind of general processing that you have to work with things like UI and so forth is generally considerably more constrained than those codec specific decoders. And I think to the point that you were making there, or that was being made a moment ago, that you don't see the hardware implementations of decoders really become common until that codec has been sort of more clarified, more specified, because you're sort of, once you make that hardware, you've really set a lot of that in stone in terms of what you can do. You don't have the ability to add a significant improvement that you might be able to make on the software side. So that is probably one of the larger things that we see slow down adoption from that perspective. And I think it's also important too to point out that where we also see hardware decoding being most beneficial, besides the cost considerations that you get from a smart TV, is on the mobile side, because that's where you really have that power concern. That CPU concern is really such a big deal. You can do software decoding on many mobile phones these days, but you're going to wind up with a hand warmer that's going to last a few minutes to go through your battery there, which is obviously not a desirable use case by any means. But then on the other hand, the benefits that you can get by being able to deliver an equivalent or better quality video experience over what's going to be a bandwidth constrained environment just by the nature of a mobile connection, even with the broader availability of 4G and 5G technologies, that benefit that you get from being that much more efficient on the network, which is always going to be a bottleneck to some degree, is I think very appreciable by end users.
Okay, that's a really good point. And somebody had actually asked a question about power consumption on what you're calling hand warmers. Do any of the other panelists have any sort of feedback on that? I mean, we need to get to hardware decoding, obviously, from the standpoint of a mobile device for power consumption issues. But what stage are we at with that at this point? And what does it mean from a device ubiquity standpoint as well?
Yeah, I think that's a really great question, and I've heard the hand warmer comment several times, so I think it's a great analogy. If you look at some of the work that Netflix sponsored to improve the decode performance with this David decoder, it has gotten considerably better over the past few months, maybe even the past month and a half, to the point where I did a kind of at-home test of just AV1 decoding on 1080p videos, and for a variety of devices going back to 2016, you could actually decode a 1080p AV1 stream using just the little cores on these 8-core CPUs. These Snapdragons, they've got 4 little cores, and I had no problem getting well above 30 frames a second doing this decode. And so I think it's an interesting question, right? Because I think power consumption ends up being multifaceted. Paul talked about the network load, right? Like downloading the content. There's also the screen brightness and a couple other things to consider. So I think it's sort of a multifaceted question that we should get more clarity on. The question is, what component of that power draws is in in the software decode, and if you offload that to hardware, like there's still some component, right? So I think we don't know the full answer there, but it is improved quite a bit over where things were, say, even just a few months ago.
Well, and it's interesting that you mentioned that about the big endian, little endian, you know, the core models, where in the classic GPU encoding scenario, we'll do CPU for audio and GPU for video. To a certain extent, if you're saying that you're able to do it on the smaller cores, then yeah, power consumption does become a bit less of an issue. Anything, Vittorio, Anush, to add to that about power consumption on mobile devices, intermittent networks, etc.?
Well, I just have a more general consideration, and that in order to develop a codec in the real world, it takes a very long time. For H.264, it took almost 10 years before we got from the standard specification to the actual physical hardware. And for HEVC, we got about half around the time, more or less. And for AV1, it has been an incredibly short amount of time. It's only 1 year old, the codec. And while there have been services already streaming on it, in order to have the best possible hardware encoder, hardware decoder, it will take some more time. But that is normal, and it's probably for the best.
Okay.
I can give you a quick one line. I think Nathan pointed out rightly about David. There was a tech blog that we published. We were already streaming AV1 up to 540p, I think, on Android devices, which meant that we as a company or as a team thought that the trade-off between the amount of bits saved and the power consumed was ideal. And it was also ideal for consumers based on our A/B testing. And we've seen the software encoder get much better. So the power consumption has gone down pretty significantly in the last few months. And we're also actually seeing quite a bit of hardware coming in for AV1 decoding, not only for set-top boxes and 10-foot devices, so TVs and so on, but also on the lower end on mobile phones. So I wouldn't be surprised if we stream high resolutions very quickly for mobile devices.
In the Android devices you're talking about, which versions of Android were you looking at, or how far back did you go? Because I know in my testing, when I do it for companies, some of them want to go all the way back to 4.4 KitKat just to see from a global standpoint.
I mean, I'll have to refer to the tech blog. Hopefully we put in what version of Android and up. Obviously, whatever version of Android ships with the software decoder is the one that we picked, but I don't know off the top of my head which one.
Okay.
Which one it is. I don't know if we went all the way back to KitKat, by the way. That's too far back.
That's fine. So one other question that came in, and there may be knowledge on this in the panel, there may not, but somebody asked about commenting on AV1 gains versus, say, EVC, VVC for similar use cases. Is that something that any of the panelists can speak to?
I know we're looking at VVC, but quite far out, I think, before we can make any meaningful discussion around that.
Okay.
Yeah, I mean, maybe I give some context, right? As we've talked about a lot, the codec was during development. There have been a lot of papers published and a lot of analysis published by different blogs, different people on which works better. Sometimes they said AV1 was worse than H.264. You can always tweak the encoder to do whatever you want. So you can make it look as good or as bad as you want, depending on what you're trying to do, right? However, if you're truly objective and you looked at production grade encoders, what we've seen is the advertised 30% or so across the spectrum, so including high resolutions, is pretty standard when compared to HEVC and VP9, which are HEVC and VP9 are approximately the same in compression efficiency. They were about 30% better than the previous generation H.264. We think that the AV1 is about the same, is about the 30%. I've seen some numbers from VVC where they've compared it to HEVC, and they see somewhere between 20 and 30%. This is from the standardization body meetings, right? But I think Paul's point is well made. Unless we have a production grade encoder, I think VVC may be a little premature to comment about, but I think they'll finalize the spec in a month or so. Then we can wait for 6 months and then we can compare VVC objectively.
Sounds good. All right, so we are down to about 4 minutes from the top of the hour, and I just want to ask each of the panelists to sort of give some closing thoughts, and I'm going to start left to right here. So on my screen, Nathan, you're up first.
Yeah, so I mean, I think we've covered a lot of ground here. And I think that the questions been asked have been very good. I think the closing thought that I would kind of just put out there is that, you know, if you're considering next generation technologies, you know, one of the things we are seeing is that there is a broad set of addressable devices that are getting AV1 support, both through the David decoder and also some of the hardware that's coming online. And so, as I think Vittorio expressed, you know, this is a lot faster than we had expected. Typically, we kind of thought that hardware would take, you know, 2 to 3 years before we start seeing things, and now there are mobile chipsets that are, you know, publicly being talked about with AV1 decode. So I do think that there's probably more availability in the market than people are really acknowledging. And I think that's an important takeaway.
Okay, good. Paul?
Yeah, I think I would actually echo Nathan's point there. We actually, in our analytics, track the addressable codecs that different devices can use. And we see in you know, North American markets, somewhere in the 50% of our customers are able to be reached with AV1, and in some other markets, that's even significantly higher than that. So the addressable audience is, I think, really getting there very quick. I think there's also a really other great point made a few moments ago, that when we look at how long it took AVC to become available and become practical in the market, then we look at, you know, how long it took for HEVC, and then we see that same pattern for AV1. That cycle is just getting that much shorter, that much quicker. So we are, I think, quite likely to see that really become meaningful to start deploying that for not just the very largest content providers like Netflix and YouTube and so forth, but really start to work its way to make sense for a much broader segment of the market to start using.
Sounds good. Vittorio?
I think one of the best aspects of AV1 is the fact that it's one of the first royalty-free codecs that is available for everybody, and that means we will see this technology more and more being spread around, especially for web-related technologies such as WebRTC. There is AVIF, which is the image format that is based on AV1, and we will see the development of royalty-free codecs continue with AV2 and whatever other codec the Alliance will provide, and that's a very positive outlook for the future.
Okay, very good. And Anush?
Yeah, I think most of them mentioned about the growing ecosystem for the decoders, so I think that's a pretty important point. The second is, it may be also worth it to mention to people who are listening in, that AVC has been around for 15 years, maybe more. And it is still the most streamed codec across the world if you look at all the different use cases. It may be time that we move on. And in general, I've noticed that there's like this chicken and egg problem. If you're manufacturing decoders or if you're writing the decoder side of it, you're looking for content, and content does not exist possibly. So you say, yeah, I can wait another cycle, and that pushes it out a year. And then if you're on the encoder side, you look and say, there's no decoder support, so I won't, the ecosystem is not there. Someone asked about device ubiquity, right? So ecosystem is not there, so I'm not going to produce it, right? But it's up to all of us who work on both sides of the spectrum, content creators as well as consumers, that it's only when there is adoption on both sides. So someone has to move, both of us should move, and that will enable, all the benefits that we've spoken about on this plan.
Very good. Yeah, in video conferencing, we used it for 5 years before it even appeared in the streaming world. So it has been here for quite some time. I'd like to thank all of the panelists for being here. Also like to thank Anil, Maria, Vladimir, Nadine, Pradeep. There were a number of people who had asked questions. Thank you for that. There was one question on licensing, and I mentioned up front, this is a technical discussion, not a licensing discussion, but perhaps Fabio, who asked the question, can get in touch with one of you, and you can point them in the right direction for the conversation around licensing. Thank you again to the panelists, and Eric, I'm going to hand it back off to you.